Previously on Brian's Mobile One. What do you think? Is it going to come out? As we come around the back side here, you can see you have a fast forward. I give up. I give up again.
Brian's Mobile One.
Howdy do, it's part two. The circumference is made shorter by collapsing it with a screwdriver. And once you ding it like that, you can just pull it right out. On the input shaft seal on this transfer case, I snuck a screwdriver in through there. I snuck it in the rubber so it wouldn't mar the other side. And then I just pried down to get that to collapse. You see like that. So same kind of thing that I did on the seal I just showed you. More than one way to skin a cat. Some people will drill a hole and put a screw in it. There's some risk involved with that too, but that's another method that you might try. And then once the screw's in there, you either put a pry bar by the head of the screw and pry it out, or put your slide hammer. These are the easiest. I don't know who came up with doing a big lip so that it's nice and straight when you drive it in, and super easy to use a screwdriver and knock it out. But we talked about that. So we're going with the Merchant Automotive thing because it's got a really big footprint here. It's like if you have a sand surface and you're trying to jack up an off-road vehicle with like a high lift jack, your jack can just sink in, but then there's like that big old platform, or you can use a 2x4 or a block of wood or something to spread it out. So that's basically what that does. You can see the difference. This works like a chisel and just works to put a hole in your transfer case half, and this just spreads out the weight, so this never has a problem. This is that transfer case half. If you look at the plugs on this thing, this is the drain hole, this is the bottom, this is the filler hole, so that would be up. So at the bottom, you see this little tab. There's a little metal thing that goes in here, that goes underneath, and is supposed to save this from doing what it's doing. You can see how worn that is. Ultimately, that metal fails. You can see it even polished this up here from the knocking. They put in that little metal thing to help prevent that from knocking, but it chews through the metal, and the metal chews through the case anyway. When you look at the case, it's a magnesium alloy, which just means that it's really lightweight. I mean, I'm holding it with my arm straight way out there. I mean, you can hold it on your pinky just about. It's just not heavy, but it's not heavy duty either. It's strong enough by all means to be a case, but you just can't chip at it like that. They'll wear. Hence the pump thing. Speaking of wear, I had a real unique wear situation here. This is the clip that holds on to the bearing. So this bearing is clipped onto the shaft that goes to the rear output, and it's got a little indentation on it. That indentation corresponds with this clip. So this is sandwiched and packed onto the shaft and held in place, and then this is held to the case essentially with that little clip right there. So in order to get this puzzle apart, you've got a hole, an access hole, and there's a little plug that you pull out of there to get to it. This case got really worn out. See, when you look in the hole here, instead of having the little escape route slot here, you can see there's another one down low. So that other little tier, you go to open this up by spreading these apart to get it off of that bearing I just showed you, and it would just hit the wall. So I had to get in there with the pry bar and pry the bearing this way to get it back up into that. It would just get stuck down there, so I had to pry it up so that it had room to expand. There's a little groove cut into this case so that you can get to it, but like I say, it just was wearing all kinds of issue with that. This poor transfer case, this was full of garbage where your pickup tube is. The nice thing about these pickup tubes, they're plastic. Let me get this off of there. You can see you've got a screen on one side, and that does a pretty good job. And then there's also a screen on the other side, so if one side gets blocked where the magnet is, it can still suck from the other side, from the top essentially. So that saved this transfer case because it was just packed full of the wrong kind of silicone. Somebody used RTV black on this, and you just can't do that. You got to use like Permatex Right Stuff Import Gray, or another one that's good to do is the EMI 5005. It's just a high strength silicone sealant. Yeah, that RTV black resists oil. Yeah, it probably won't leak, but yeah, it's going to go all through and plug up your pump and make a huge mess and cost you a ton of money. So to get this back in, you just got to put it up in the magnet spot, and then from there, gotta work it back down and then in. There we go. And then you put the magnet in, it holds everything pretty. When you go to put this all back together, I don't know if I was real clear on this before, but putting the little tube to this, and as far as the way that this lines up on the transfer case, there's a hole here for the pickup tube. This is the pump. So when you go to put this on, you spline it, and then you rotate it until this points to this guy. And then what I do is I just kind of turn it, wiggle it, push it, get it to go in like that, and it basically holds it in the right position. So if you forget, it doesn't matter, it only goes in one way. We'll take our magnet, throw that in over the top of our filter screen. So this is the tone wheel for the speedometer. There's a little magnetic sensor with a permanent magnet, does a little AC. You can see where it's been magnetized, there's a little metal thing in there, just a little, it doesn't hurt anything. But this is the small side that fits down into the pump, and then the smooth, normal side goes out. So just spline that up, throw it on, and then the bearing, or little groove in the bearing, goes to the back, or the out. Can I come into the out now? Alright. This bearing is in great shape because it doesn't have any play. It's awesome. And then you got the circlip that goes in this little groove here. You just use your expanding pliers. I like these because they have a nice waffle cut into them. You just take it like that. I just hold it, no real pressure to speak of. And then when you get in close, spread it out, get it on there, and then just push it the last little bit. Don't use your fingers or your gloves get pinched into it. Done that a few times. Next thing I'm going to do is I'm going to clean these case halves. I got all the silicone off of it. I used a little brass brush. I just use one that's real worn out and flat, and that way it holds the little pieces of silicone for me so I don't have to go chasing them so bad.
Stabby, stabby, stabby.
And just go with the grain on this. There's a machine grain to it. It will come right off, and that's how it ends up in the pump. We'll get some brake parts cleaner now that this is done, and then we'll use the right kind of stuff. You can either use Permatex Right stuff, which I love, or you can use this. I'll use this because it came with the kit. We'll throw these cases together. The good side about using this is it works great and it doesn't get into the pump. The bad side about it is that it's a little bit of a bugger to apply, meaning that I like to have like a needle nose point, and this you just kind of have to slop on there. It works though. If you use too much, remember that it's going to stick down into the transfer case. If you don't use enough, it's going to leak. Now, how much is the right amount? I try to go about 0.75 millimeters or a millimeter thick and just kind of get a little bead going on. This is a little too thick, but I tend to err on the side of too thick as opposed to having to take it out and split it again. So here's my final hack job of this. If I had the time and resources, I'd make it look like some kind of laser jet or inkjet printer, put it on there. But this will have to do. This will definitely seal it, but I'm going to have a lot of slop. But fortunately, if you use the right stuff, it's not going to end up in your screen. We've got the case halves together. The next thing we got to do is put blue Loctite on all these bolts. If you don't do this, they will work out, and that doesn't make things work out for you. Just a little on each side, just something to say, hey, I want to hold you. So here's that rusted surface that we need to get this pain in the neck, difficult seal onto. We don't need things to be any more difficult with this, and that's why we're going to clean this off. Oftentimes you can just use steel wool, but whereas this is an older truck and the rust is really etched in, we're going to use a little bit of fine sandpaper. Now I'm not going to do that on camera because I have to tip it up to get it to show. So rather than do it on camera, I'm going to do it off camera. But I'm just going to work it side to side like this, get my finger up in there, and then I'm going to rotate it and then do it again and repeat as needed. So here's what the process looks like. I've got the 220 grit, which I thought would be too high, but it's only effective for the first few strokes, like maybe 10 strokes, and then it becomes clogged with rust. So when that happens, you can flip it off, blow it off, whatever, or rip it off. You can see this has a couple of holes in it. It's been on a sanding block, and it's just the waste that I save for stuff like this from doing body work. So we just repeat the process. I just rotate it slowly. And then you'll notice that there's a decline in the return you get for each stroke. And when you notice that, stop it, rip it, and then go again. As I said before, I got to do this facing down so that I don't contaminate the bearing that's behind there. I got to keep everything going down and out. You just go through and wipe it out. I don't like using sandpaper. I'd rather use steel wool, but the steel wool just was not getting me any progress. As you can see, the sandpaper has. This is the part I haven't worked so much. This is the part that I've worked pretty well. this is going to snag on that new seal much less, especially once I lubricate it a little bit. I got tired of sanding. I went to the Dremel and I just used one of the wire brushes that was worn down. This is where I use the Dremel, and it's smooth, it's good enough. It doesn't look as good as where I sanded. Where I sanded actually takes it down into the steel a little bit. Where I did it with the Dremel, it just removes the rust and the softer particles. But either one's acceptable, and that's the results that you can expect. Sanding, I spent maybe 10-15 minutes sanding. Dremel, I took maybe 45 seconds to a minute. It didn't seem like very long at all. So I'm just going to use a dead blow hammer side. My eye, you can't really see what my eyes are doing, but I'm looking straight down this and just looking to make sure that it's even all the way around. I need to brace and support that. That's what I need to do. Alexa, stop. So you can see I've been driving this in. It's nice and even all the way around. And then all of a sudden this starts to resist. So when this starts to resist and this becomes a lot lower, you need to switch, and we'll do this for a little bit. This ball joint press ring is like beautiful for this. Another thing you'll notice is that I've got this nice and flat on the workbench, and I'm just leaning up here, hello, to hold it in place. And that way you can use your instincts for what's level to help monitor the seal. This is actually a surprisingly helpful tip. I'm long past due to have this job done, so I had to do this off camera. Not to mention I need a camera person bad. But you can see that this doesn't go all the way. So what I did to finish up, or follow up, is I took my blind seal hole puller. This is just about the right size and shape. I just went around a tap here, tap there, and just kind of then I worked it in a circle. So now it's just nice and flat. You can see the inside of the floating seal move. Voila! Beautiful. I mean, this is a challenging, difficult thing. Knowing that the large size cup on the ball joint press fits this perfectly is really nice to know. Knowing that a 12.42 millimeter socket's good for the inside for a little bit and then just drift it in the rest of the way. By the time you get it done with the socket, it's down so far that it's already even, it's already moving, you're already okay. So then you can just do the rest. So the next thing we're going to do is we're going to drill a hole in the end of the drive shaft, the little slip shaft part of it at the very front of the rear drive shaft, if that makes sense. So we take the micrometer, or micrometer, depending on where you're at, and it wants it to be about 0.24. That would be ideal. The closest drill bit that I have happens to be 0.225, which is close enough. If you wiggle the bit just a little bit, it's going to be fine. And this is a grease zerk. This is pipe fitting stuff, so you don't have to be completely precise. So what we need to do is determine what the thread pitch for this is. And I already know that it's a 28 because of the package, but I use this little thing from my tap and die set to verify. And then you just get a tap to match. This one says 1/4 by 28. And when we check this with what we did on our drill bit and with this, you can't get it directly across because it's a triangle. But you can get close enough to see it's just right there at 2/4. The other thing that I really like to use for this is the Bow Lube. It's a Boeing product. They developed it for manufacturing aircraft, and it just really makes your cheap Harbor Freight drill bits not die the first time you use them. It's a lubricant, it helps with cooling, it's just awesome. This is a little demonstration. This is the front drive shaft on this 03 2500 HD. Rear drive shaft, they actually spline together. So if you have some play, you can actually rock them and twist it like this and see if there's play in there. There's basically little to no play here, so there shouldn't be a great issue with knock on this one. There was some issues both with the Ford and Chevy when they didn't use the right kind of chromoly or whatever it is. This is the rear drive shaft. It was rusted the same as the other ones all the way out to about here. So I took it and buzzed it on the wire wheel on the bench grinder. You can see it's cleaned up pretty nice. We're going to drill this and insert a grease zerk. We want to do that in that rust band where you don't have any influence. It takes a lot of grease pumps to get the grease out here, but once you do, it'll save your drive shaft from doing all kinds of noises. I forgot there's more tools involved. We're going to use a punch, and we're going to punch where we're going to locate this. We're going to do it in that rust band that I cleaned off, preferably toward the back. It's going to take a lot of grease to fill that cavity at first, and then it's going to fill in and go back. It's going to smash grease out of it, so just expect that. So we're going to punch it, then we're going to locate the drill bit into that punch hole, drill a hole all the way through. We're going to put some Bow Lube on this as well. We're going to just work this down in there, We're gonna work it back out. So this is where I've chosen to put mine. It's because I need room to get the grease gun in there, and I need to be in the rust band. The rust band was right here. So I've got room to put a grease gun on. I have good access. It's far enough back that I'm gonna be able to clear everything I need to clear, but far enough forward that I can get the grease in and hit the hollow spot. So we're gonna dip in the stuff and then put it in. I should be just about through. Get some more bow lube and go again. It'll start to chatter there. No way a drill bit from Harbor Freight would do this without the bow lube, I'll tell you that. Starting to get into the coating, you can hear it. Shavings mean we're still cutting good. You don't want to stay too long, even though you think you're going to go through. Oh, you know what I'm doing that's stupid? I don't have these apart. I think I'm drilling into this other drive shaft. I've drilled far enough, I should be through. Alright, let's make sure to leave a gap. And it shows. I got into that pretty far. I almost went all the way to where the thing is. So yeah, bow lube. This is hard metal. It just went right through it like it's nothing. Boy, this sucker's hard. I think my hole was too small. I forgot to wiggle the bit in there. Let's do that real quick. There we go. Problem solved. I want you to honestly tell me, have you ever wiggled a drill bit to get the hole you needed? I hate doing that because you know it's not going to be perfectly round. But whereas I'm putting threads into the thing, it's not going to matter. You can see I'm not perfectly straight. I'm not exactly perpendicular. But it's good enough for a pipe thread, grease circ. Better than it was, that's for sure. What if the grease circ falls out? Here's a good question. Is it going to get water in? Yeah, but this thing about the RPMs this is turning, anything that gets in, this is going to work as a drain plug. Somebody at the back of the class is saying, hey, what about balance? Well, we took metal out, and that would create an imbalance. And we're going to put more metal back in, so your balance is going to be close to what it was. I mean, not exactly, but you're not far away from the point of rotation either, which also makes a difference. I always say the back of the class because that's where I used to sit for a lot of my classes, and I'd come up with those kind of questions. So you feel like you're off on your own. You're in your own little world. Ooh, that threaded in pretty. It's just going in that smooth. If you don't want to strip it out, just get it in there. Pretty. We're just going to flush out all the metal shavings that are in there from threading it and from drilling it, and then we're ready to go in. So here's another little tip. This is on that front drive shaft. When you go to take these clamps off, you can reuse them. These are the best clamps in my opinion to use. They're CV axle boot clamps, but you need a special tool for it. It pushes up and at the same time pinches closed. So what I do is I expand this by just spreading it, working the screwdriver back and forth, twisting it, etc. Unhook it off of there, and then make sure when you put them back on, rebend this so that it's a match of the arc or curve of the clamp here. So here's what it looks like using the tool. You just go in there, it just pulls it tight, and then that thing is just not going anywhere. Super great little clamp, super great tool. It's easier if you have the right tool. That's transfer case tips for this video. Hope you enjoyed it. I just tried to throw in all the stuff that I couldn't find anywhere else, stuff that people didn't want to show. I mean, it's tricky, difficult stuff. It's good to know the tricks, but who wants to be the guy to put his name on it, you know, when it's not a pretty process, if you know what I mean. So if you like the video, be sure to click like. If you subscribe, it'll notify you of any other videos, contests, or things that I have coming up. And love you guys. Really appreciate your support. Cheers.
Bonus footage at the end.
So I got a Rubicon in the mirror. I got an Abarth 500, and I got a couple of Cats, the Challenger and the Charger. We're at Lake Elsinore, and I was thinking, man, that hillside would be so awesome for ridge soaring and stuff. And then sure enough, you zoom in, you can see vultures just circling above it. It's like an awesome, awesome place to fly, but nobody flies here that I know of.
I guess this guy flew.
Except the Pacifica.